Welcome to Basics of Electricity. Electrical Safety the Easy Way from My Safety Training Online. What topics will we cover? We'll discuss the physics of electricity along with definitions, the body and electricity, how burns occur, power lines and electricity, cranes and power lines specifically, the GFCI, ground fault circuit interrupter, and how electricity kills, how to use power tools correctly, including proper grounding, and abuse of power equipment. The basics of electricity, the physics. Electricity is like operating with an electrical switch when it's turned, like turning on a water faucet. Behind the faucet or switch, there is a source of water or electricity and a way to transport it, and pressure to make it flow. Three factors determine the resistance of a substance to the flow of electricity: what it is made of, its size, and its temperature. Here we can see a flow chart of the transmission line, disconnect switches, circuit breakers, and transformers, in showing how electricity flows using physics. Definitions and basics of electricity. Substances with very little resistance to the flow of electrical current are called conductors. Examples of this would be metals. Substances with very high resistance that can be used to prevent the flow of electrical current are called insulators. Examples of this are glass, porcelain, plastic, and dry wood. Electricity travels in closed circuits, normally through a conductor. Shock results when the body becomes part of the electrical current. Current enters the body at one point and leaves at another. Here you can see it depicted. The three primary factors affecting the severity of a shock a person receives when they are part of the electrical circuit are the amount of current flowing through your body, as measured in amperes, the path of the current through the body, and the length of time the body is in the circuit. In discussing the relationship between electricity and the human body, we can look at this chart here and get an idea on how many milliamps can affect the human body. 1 milliamps gives just nothing more than a perception level, a slight tingling. 5 milliamps gives you a slight shock. 6 to 30 milliamps gives you a painful shock, as well as muscular control is lost. 50 to 150 milliamps cause extreme pain. 1,000 to 4,300 milliamps ventricular fibrillation. And 10,000 milliamps you get cardiac arrest, severe burns, and probable death. Shock-related injuries include burns, internal injuries, injuries due to involuntary muscle contractions. Burns are usually the most common. Burns are suffered in electrical incidents with one of three types: thermal contact, flash burns, and internal injuries. Excessive electricity flowing through the body can cause serious damage to internal organs, usually resulting in medical problems including hemorrhage, tissue destruction, nerve and muscle damage, as well as involuntary muscle contraction. Power lines and electricity. Overhead and buried power lines at your site are hazardous because they carry a high voltage. Examples of power lines are aluminum paint rollers, backhoes, concrete pumpers. Look out for overhead power lines and buried power line indicators and post warning signs on those locations. 30% of approximately 350 electrical-related fatalities that occur each year involve cranes and overhead power lines. If contact does occur, proper safety procedures should be followed. The danger posed by overhead power lines at a construction site are compounded by other factors. Here we can see a depiction of cranes and power lines. Remember that the higher the amperage of a power line, the greater the distance the crane must maintain. GFCI, or ground fault circuit interrupters, on all 120 volt single phase 15 and 20 ampere receptacles, or have an assured equipment grounding conductor program called an AEGCP. Follow the manufacturer's recommended testing procedures to ensure that the GFCI is working correctly. Ground all power supply systems, electrical circuits, and electrical equipment. Frequently inspect electrical systems to ensure that the path to the ground is continuous. Visually inspect all electrical equipment before use. Take any defective equipment out of service immediately. Never carry a tool by the cord and never yank a cord to disconnect it from a receptacle. Avoid accidental starting by not holding your fingers on the switch button when carrying a plugged-in tool. Disconnect the tools when not in use before servicing and when changing accessories such as blades or bits. Use of power tools on construction sites with flexible extension cords are often necessary. Because they are exposed, flexible, and unsecured, they are more susceptible to damage than is fixed wiring. Hazards are created when the cords or cord-related and plug-connected equipment are improperly used and maintained. Grounding a tool or electrical system means intentionally creating a low-resistance path to earth. The term grounding refers to a conductive body, usually the earth. System or service grounds. In this type of ground, a wire called the neutral conductor is grounded in the transformer and again in the service entrance to the building. It is primarily designed to protect machines, tools, and insulation against damage. There are two kinds of grounds, and both are required by OSHA construction standards. Equipment to ground. This is intended to offer enhanced protection to the workers themselves. If a malfunction causes the metal frame of the tool to become energized, the equipment ground provides another path to current to flow through the tool and to the ground. Using multi-receptacle boxes designed to be mounted by fitting them with power cords and placing them on the ground, fabricating extension cords with Romex wiring, using equipment outdoors labeled for use only in dry or indoor locations, using circuit breakers or fuses with a wrong weight rating for overcurrent protection all present hazards. Here we can see a crane contracting the overhead power line during a freeway construction recently. In the second photo, the crane contacts the overhead power line during the freeway construction, resulting in a fire on the ground. 46,000 volts travel to the crane and beneath the concrete road. In the third photo, An eyewitness stated in a split second, the whole crane, cab, and everything else exploded in flames. A fire chief later stated, electricity will find its path, and if you're in that path, it will injure you. In this photo, we can see the hydraulic fluid of the crane and the underground installation become fuel for the flames. Slabs of concrete are lifted in the air in the subsequent explosion. Debris rained down through smoke and fire, and the roadbed became fully engulfed in flames. In this final photo, we can see that the crane operator actually escapes with only minor injury, despite the subsequent inferno of the crane and roadbed. Power hand tools and electricity. Handheld tools manufactured in a non-metallic case are called double insulated. If they are approved, they do not require grounding under the National Electrical Code. Although this design reduces the risk of grounding deficiencies, a shock hazard can still exist. When discussing grounding electricity, a wire called a neutral conductor is grounded at the transformer and again at the service entrance of the building. This is primarily designed to protect machines, tools, and insulation against damage. It also is intended to offer enhanced protection to the workers themselves. If a malfunction causes the metal frame of the tool to become energized, the equipment ground provides another path for the current to flow through the tool and to the ground. A ground fault occurs when there's a break in the low resistance grounding path from a tool or electrical system. The electrical current may then take an alternative path to the ground through the user, resulting in injuries or death. The GFCI is a circuit breaker designed to shut off the electrical power in the event of a ground fault within 1/40th of a second. Types of GFCI. Receptacle types, portable types, and cord connected types are three types of GFCI. Electrical safety summary. The GFCI can control electricity in 1/40th of a second, while power hand tools should be double insulated. Flexible cords are more susceptible to damage than fixed wiring, and system and equipment grounds are the two types of grounds that exist, while burns are the most common types of electrical injuries.